Welcome back. Today we'll be building another audio amplifier circuit. We'll be working with the LM380. And this amplifier, in my experience, is not a bad amplifier. It's just not quite the sound that'll come out of the other side of it. Once you build a circuit, you can build a really good circuit around it and make it sound fairly well. It'll never be high fidelity. It was never intended to be. In some sense, this is a microphone amplifier, and in one where you're not overly concerned. You want an amplified signal out of the other side. You may not want it to sound absolutely perfect. The LM386 or the LM383 that land on the lower wattage side and the upper wattage side of this tend to sound better, to me at least. Maybe it's just me. I can build better circuits around the LM386 or the LM383 than I can the LM380. A professional audio engineer that works with such things every day could obviously do better. But it's an interesting chip amp. It has an internally fixed gain of 50, which comes out to be around 34 decibels. You can use a feedback loop to increase that gain if you want to. You just have to be careful not to exceed the wattage that the chip can actually dissipate, even with a heat sink. There are some other interesting things to pay attention to on the data sheet. That it can be prone, like all amplifiers, to distortion and oscillation, but it's not quite as bad. It's easier to get this chip up and running than it is something like a LM386 or a LM383. But even with the best circuit around it, the sound coming out of it, just to my ear, is not quite as good as either of those other two. But as long as you pay attention to the data sheet and you add in the appropriate bypass capacitors and capacitor resistor network on the output line, you can end up with something that sounds fairly well at the end. And we'll see that as we go along. Let's look at the circuit. The diagram we'll be going by for this circuit is this one. You can pause the video and copy it down if you would like. Can't get it all on the screen given the orientation of my camera, but that should give everyone a pretty good sense. The component values, we'll go through them as we build the circuit, and I'll also include them in the description at the bottom of the video. But there's the whole circuit. The first thing we'll need is just a breadboard. I've connected the positive and negative rails. This breadboard separates them in the center on this side. I've connected the negative rail on this side, and I've added a jumper from the negative rail from one side of the board to the other. The first thing we'll need to do, I've put the LM380 chip in, starting with pin 1 in this position. We'll need to connect our power supply. I'll just be using a 12-volt battery pack, which works perfectly fine to test the circuit out. Now we have our battery clip in. The first thing to do is go to our sheet. And from VCC, we have a 470 microfarad capacitor, followed by a 0.1 microfarad capacitor decoupling the input or the voltage supply line to the chip that goes to pin 14. 470 microfarad capacitor, paying attention to the polarity, the black line goes to the negative rail. And this just creates a charge supply when the amp tries to draw. When we increase the volume, it'll draw more amperage, and in turn it'll generate more wattage out of the speaker, and this just gives us a buffer when the audio signal swings from high to low. There's the setup. Then a 0.1 microfarad capacitor. Generally with these amp chips, you want to use something like polyester if you can, especially on the inputs, unless it's just too big and you need electrolytics. But I don't have that many polyester at the moment, so we'll just use a simple ceramic. We'll put it in breadboard like that. Orientation doesn't matter with the ceramic capacitor. And we can go back to our data sheet. And we have a wire going from VCC to pin 14 of the chip. Pin 14 is right there, the topmost pin on this side of the chip. Now we have a wire going from pin 14, from the positive rail to pin 14. That takes care of the first connection to our chip. And on the LM380, pins 13 and 9 are not connected, so we don't have to worry about them. And then we need pins 12, 11, and 10 go straight to ground. This serves as the same, if you'll notice, occurs on the opposite side of the chip. These pins 12, 11, and 10, as well as 3, 4, and 5, provide the heat sinking. And then you can build a little heat sink. It's described in the datasheet for the LM380. And if you want to even a better diagram of it, you can look at the datasheet for the LM384. And it shows a real nice description of how you can build and attach a heat sink to this. And you might need that if you're going to run it at that upper wattage level. But for our purposes, just to test it out, get ourselves started, we need some wire going from pins 12, 11, and 10 to ground. There's pin 12, 11, and 10. We have those connected. We have pin 13 empty, and we can leave pin 9 empty. Moving right along, we can move on to pin 8 toward our speaker connection. We need a piece of wire coming off of pin 8. Here's pin 8 in the bottom, very bottom row right there. We leave 9 empty, then 8. Then we need our oscillation protection resistor capacitor network. We need a 1 microfarad capacitor, and the datasheet points to 2.7 ohm resistor. I'm just using a 2.5 ohm to ground. 0.1 microfarad capacitor. This is a polyester. And it's just in there like that. And 2.5 ohm resistor. And this will just cut down on on a little bit of the distortion that might occur in when the speaker's working back and forth, as well as if there's any noise, a last ditch effort of any noise that's been amplified during the chip's amplification stage. This will cut a little bit of it out. There's how it hooks up. Then we need, so we have this taken care of. So now we need that 470 microfarad capacitor, then wire to our speaker, 8 ohm speaker. We can stretch it out so it's easier to see. We can add in a wire. And we can add in our 470 microfarad capacitor. Paying attention to the polarity of it once again. The positive side is toward the chip, the negative side is toward the speaker. There's the negative side with the line. That's in. Now we will need a way to connect our speaker. Unfortunately, the little speaker in the SparkFun box I normally use doesn't have enough wattage to use with this, so we'll have to be connecting a larger speaker to it. So I'm just going to add in a piece of wire that I'll use alligator clips to connect the speaker to at the end. And then we'll need something to attach the negative side of our speaker to ground. I'll add in another little piece of wire to the ground rail on this side. Notice that I'm going to keep the input ground on this side of the breadboard, and the speaker ground will be on this side. That'll help cut down on a little bit of oscillation, noise, the crunchiness as it plays. That takes care of the right hand side of the circuit diagram. We have our VCC decoupled, we have pins 12 through 10 to ground. We have our speaker circuit connected. We just haven't hooked on the speaker yet. So we can move to the other side and notice, just starting at the bottom, pin 7, 6, 6, which is the non-inverting or the inverting side of the op amp inside the chip, is going to go to ground. So 3, 4, 5, 6, 7 are all going to go to ground. And 3 to ground. That's pretty easy, pretty straightforward. There is ways to connect the input rather than, as we're going to do it, to the non-inverting side of the op amp. One can connect this input to the inverting side with some other connections. It's just one will need to look at the data sheet, and I would encourage them to look at the data sheet for the LM380 and the LM384, as well as do some Google searches and check it out. There are ways to send our audio signal through the inverting side just as well as the non-inverting side. For our purposes, we're going through the non-inverting side, and we have all of these connections made right there. So all we have left is pins 2 and 1 to take care of. Before going to pin 2, which is the actual audio in, we'll take care of pin 1, which is a 0.47 microfarad capacitor. This is the bypass pin, and the data sheet suggests we connect it to remove some harmonic distortion. So sometimes one strays from the data sheet, but in most cases we do our best to follow along. 0.47 microfarad capacitor. It's 474s on the case. Goes from pin 1 to ground. You just add it in like that. From pin 1 to ground. And now for the actual input side. This bypass is on the input line too, so you definitely, when you use your bypass, keep it over here. Keep your speaker ground over here. It'll just help in the long run. And remember, the LM380 is not going to give you the best sound to begin with. It'll give you decent sound, but it doesn't need any help sounding a little crunchy. So there is pin 2. This will be our input. We can use a little piece of wire to get past it. That's just a piece of wire in pin 2 going up. And if we look at our circuit, we'll need a 10 microfarad capacitor to cut any DC coming in on the line from our MP3 player, as well as you won't hear it pop and crackle quite as bad when you plug it in and give power to it. So we notice the polarization. The negative side will go toward pin 2. The positive side will be toward our audio in. Negative side. You just put it in like that. The negative leg's in the same rail as that wire coming from pin 2. Then we can add in another wire. And at this point, before we move much further forward, we have our 10 microfarad, then we have this 470 picofarad. I add this in just to cut a little bit of radio interference, like when you have the circuit powered up but you don't yet have your MP3 player playing. This will cut some of the RF interference that you might pick up on the speaker. This value, you can play with this value depending on how much radio noise is in your area. Like I live in a building with quite a few other people and they're playing radios from time to time. Almost every time I go to build an audio amplifier circuit, I can always pick up some RF. And this will help. You can increase or decrease this value, generally sticking in that picofarad range to try to cut some of that out. You just have to plug it in, don't power up your MP3 player, and play with some of these values. See when you stop hearing the radio interference. Here's a 470 picofarad capacitor. We'll jump it on the line, and notice that I've just put it on in the same row with the line that will be coming from our potentiometer. This will connect to the center pin eventually, and this will just cut a little bit of the RF, and then the signal will carry on to the amp itself. Breadboard friendly 10K potentiometer. We can go ahead and hook a ground line in just to ease. It's just easier to do so. We can line it up, see about where the center pin of the potentiometer is going to be and where ground is going to need to be. You can go ahead and hook in ground on the third leg, and then the center pin of the potentiometer needs to line up with this green wire. Just like that. There's the center leg, there's ground, and we should be at the point. We've just did this and went to the center pin, grounded our potentiometer. Now we'll need a positive audio in, then the audio ground will go to the ground rail. To do that, I'm just using the same old stereo jack I've used in all the other videos, with the right speaker wire. The left is just taped and tied off. This is a mono audio amp, so we only need one wire. The positive audio wire is going to go to the first pin of the potentiometer. It's going to that first pin. And then the ground will go into the ground rail of our breadboard. And that should be the circuit. Let's zoom out. And all we have left to do, connect our speaker, connect our power supply, and music player. I'll be using this speaker outside an enclosure, so clearly it won't sound as good as it would if it wasn't in an enclosure, but it'll give everyone a sense of what to expect from this circuit. And we'll just use alligator clips. This is just the prototype stage of building the circuit. Clearly you would put it on proto board and put your speaker in an enclosure, etc., etc. As you go. This is a 4-inch speaker. The one I normally use is a 3-inch, but it doesn't have the wattage to really handle what this amplifier can put out. And moreover, this amplifier tends to sound better with a larger speaker. That's just something to note. So we have the speaker connected. We can connect our 12-volt power supply. Use these batteries. And before attaching our power supply, we can connect our MP3 player. You can connect it afterwards too, but it just will stop on the crackling, the noise. And then we just plug in our 12-volt supply. No RF interference initially. That's good. Then let's try it out with some songs. First song. And you can adjust the volume with the potentiometer. Try to give it a little bit of enclosure. I don't know how well that'll translate through the speaker on the camera, but not bad. Now for another song. It doesn't pick up the low sound quite as much as one might want. We wouldn't be finished until we did at least one run of Bach. Well, that should give everyone a sense of what to expect, or somewhat what to expect. Like I said, the LM386 and the LM383 tend to be my more favorite of audio chip amplifiers, but this little LM380 works well enough for what it is, especially given that it wasn't initially perhaps designed to give the greatest of audio sound out of the other end. It was an audio amplifier, but not quite as fancy as the LM386 or the LM383. And for those who might want the circuit again, here's the diagram. We'll put it up there one more time. We'll zoom out a little bit so that those who might want to, that's the maximum zoom I can do at this point. And one thing to keep in mind about the LM380 is that if you do want to increase the volume to try to drive speakers larger than this little 4-inch 5-watt thing that I'm messing with, granted 5-watt speakers way more than this chip can put out, but you may want to think about looking at the datasheet for the LM380 as well as the LM384 for how to construct a heat sink to attach to these pins and continue to ground them. But in the end, it's not a bad little chip, and I hope this video has been helpful. If it has and you like the video, please consider clicking like and also consider subscribing to my channel. Thank you.